Hi, my name is Anargia, and I'm a junior at Light Ridge High School in Northern Virginia. And my paper focused on the current treatments for glioblastomas and some emerging developments that are being done in this field. So currently the most common, so glioblastomas are a type of brain cancer, and they're known to be very aggressive. So some of the common treatments for this cancer consists of like surgery, chemotherapy, radiation therapy. Usually it's like a combination of these therapies, but a big problem with these therapies is that they can be very invasive. So if you take like surgery, for example, like there's a high chance that you can affect surrounding cells of the tumor that are healthy. So you're causing further damage than needed. And also some of these treatments haven't shown to be as effective as they could be. So the overall question I wanted to answer in my paper was, how can we make glioblastoma treatments less invasive, but also more efficient? So the focus of my paper, I talked about like the benefits and drawbacks of the standard therapies, but then I focused on two emerging treatments, which are tumor treating fields and nanobots. So nanobots are like little machines or robots. They're very small, as you can see in this picture right here. They range from like 1 to 1,000 nanometers, and they help a lot with drug delivery. So one paper that I read, they coated the nanowires of these nanobots with tumor necrosis factor cytokine, and through imaging and fluorescence imaging, they found that these nanobots are able to translocate nuclear factor kappa B, which is a regulator of immunity. So this shows that these nanobots are able to specifically target these glioblastoma cells, and they're able to effectively deliver drugs. So again, like it's a very specific treatment because they can be controlled through like electric fields or magnetic fields or heat. So there's a high level of control that comes with this treatment. And nanobots can also help certain stages of the cell cycle, and they help a lot with drug delivery because they help overcome drug resistance, and they also help the drug from like degrading. They help with the solubility, and they extend the half-life of the drug, so it helps a lot. And one clinical trial that I saw, this is actually like the first in-person trial, because there hasn't been a lot of research done on nanobots in glioblastoma since it's so new. But they used these gold nanoparticles, which the core was filled with a drug for glioblastomas, and they administered through IVs. And what they found is that the drug did accumulate in the tumor cells, which shows that this treatment is able to effectively target these glioblastoma cells. Another treatment that could be proposed are tumor treating fields. So basically, this treatment uses alternating electric fields through transducer arrays, as you can see in this picture right here. So basically, tumor treating fields work by affecting the mitosis of rapidly proliferating cells. So they typically tend to target cells that are in the stage of metaphase, and they do this by affecting the spindle formation, which causes chromosomal breakage, and it signals the cell to have cell death, which is also known as apoptosis. And then also the tumor treating fields, they can increase the permeability of the plasma membrane, and this helps with the absorption of certain drugs. So a lot of the time, this treatment is given with like chemotherapy, and these chemotherapy drugs are able to better accumulate in the glioblastoma cells, especially by like translocating like tight junction proteins. So this helps with the efficacy of the treatment. So one of the companies that's currently developing these tumor treating fields is Novocure, and they had this trial done where they had one group of patients with tumor treating fields and a chemotherapy drug called temozolomide, and then they had one group with just temozolomide, and they found that the 6-month survival rate for the patients who received tumor treating fields was 56%, but it was only 37% for patients that didn't receive tumor treating fields. So a lot of the information I found was by assessing various clinical trials that have been done across the globe and sifting through like various research journals. So big findings that I saw were that tumor treating fields are very effective in only affecting rapidly proliferating cells. They don't affect nearby cells like surrounding the tumor cells. which makes them a very like safe treatment. And then also it's been shown to increase the 5-year survival rate from 5% to 13%. And this is a really big deal considering how aggressive glioblastomas are. And nanobots, the big advantage that I found through various journals was that there's a high degree of like control that comes with it. So they can cross the blood-brain barrier and specifically target only the not tumor treating, the glioblastoma cells, but they don't affect healthy surrounding cells, which like minimizes the damage of these treatments. So again, the main question I wanted to answer was how can we make this treatment less invasive and more effective? So again, like tumor treating fields, like they hit both points of this question because they're less invasive because they're administered on the scalp. It's an external treatment. So it mitigates some of the concerns with treatments like surgery where you're affecting a lot of healthy cells that don't need to be like affected. And then they're also more effective because you're increasing the permeability of the membrane by moving junction proteins like claudin 5, and this helps with the uptake of drugs like chemotherapy. And then nanobots, they're still fairly new. There's not a lot of research that's been done. So researchers are working to experiment with like different shapes and sizes and materials. But through this research that has been done, it's been found that they are very specific and they are able to effectively deliver drugs to the glioblastoma cells. So I feel like through my paper, I was able to propose like options that aren't as heard of. I feel like a lot of time when people think of cancer treatments, they think of like chemotherapy or like radiation, but like through these therapies, it's a much minimally invasive, but it's still able to effectively treat glioblastoma, which is such an aggressive cancer. And I feel like with the dismal survival rates, these treatments are able to effectively cure glioblastomas to some extent. So I had a really good research experience with gifted Gabber. I got a lot of valuable insight from both professors. I feel like Professor Virgil helped a lot with making my paper more concise, but still making it engaging to read. And I feel like I clearly knew what the paper was supposed to consist of. And Professor Prahlad helped a lot with clarifying topics that I might have misinterpreted. Like sifting through journals, it's a lot of like new information. So there are parts that I kind of misinterpreted, but he was able to help me properly understand my topic. And he also provided a lot of like valuable ideas that helped expand my paper. And yeah, that's it. Thank you.
Awesome, Anargya. The level of detail of your presentation, I'm pretty sure your research has that as well. It is pretty darn amazing about all the nanobots and the way you've gone in. This is just the beginning, and we want you to pursue this further and bring in a lot of achievements into the field of research of glioblastoma. So it's wonderful. Thank you very much for being here and continue that. Okay, 2 questions for Anargya.